So this is, I kind of made this as a resource page. So I'm giving you the parent function and then graphing it in standard, vertex, and intercept one time through each. So this might seem fast, but then we're going to process it and practice it in a minute, but at least you'll have gone through one of each. Then if you want to move faster than me, you can. If you want to stick with me, you can. So we know that the graph is called a parabola. And the parent function, I'm just going to put this table of values up there again, because if you don't know this table of values, you need to. It should stick in your brain that when you square the negative number, right, you get positive numbers, and our points are always 9, 4, and 1, right? 0, 1, 4, and 9. Symmetric on both sides of the vertex. The vertex is at 0, 0, and then 1, 1, 2, 4, and 3, 9. So just reviewing the parent function from your quiz. Maybe this will seem a little bit easier because we spent some time on quadratic last week. It has concavity, so this is considered concave up. And we're going to look at some that are concave down. All right, so standard form is what we haven't looked at yet this year, but you spent a while on standard form in Algebra 2. So standard form is ax squared plus bx plus c. And this is what our calculator gave us for that projectile problem. They gave you the coefficients of a, b, and c. And so there's kind of rules. When it's in this form, to graph it by hand, you're going to follow these rules. So here's our example that we're going to graph. So your first step is just to identify what is A, what is B, and what is C in this problem. It's in standard form, meaning highest to lowest exponents already. So I can just see that A is 2 because it comes first, B is -8, and then C is 6. But if they give you the problem like jumbled up, like -8x plus 6 plus 2x squared, you have to put it in standard form first. So don't ever read a quadratic that's jumbled up. Take a minute to rearrange it. It'll help you with factoring and graphing. All right, so now your first step is, what does A tell you? So A gives you the concavity. So this is concave up, right? Because A is +2, and it's going to be steeper, right? Because A is 2. So you've got two pieces of information, just thinking about what the graph's going to look like. Concave up and steeper. And then number 2, you do your vertex calculation by taking the opposite of B over 2A. That should be kind of a memorized formula. If you've forgotten it, we're going to use it a lot today and tomorrow. So the opposite of B all over 2A. So to find it's actually the x value of the vertex. Negative B is going to be +8 for this quadratic because it's already -8. So the opposite of B would be +8. And then you're going to take 2 times the A value. So 2 times 2 gives you 4. So the x value of the vertex, 8 divided by 4 is 2. So then you're going to plug in 2, right? So x is 2. I'm going to plug 2 into the original function for all those x's to produce my y value. So I'm going to do 2 times 2 squared, right? Because it says 2x squared. And then it says -8x. So I'm going to write -8 times 2. And then it says add 6. So +6. So I plug in 2 to the original function. 2 times 2 squared -8 times 2 plus 6. So I have to do some mental math here. You always do your exponent first, so don't do 2 times 2 first and then square it. 2 squared is 4, and you're doing 2 times 4 to get 8. And then minus 8 times 2 is 16, so -16, and then I'm going to add 6 at the end. So 8 minus 16 is -8, plus 6 gives me a y value of -2. So my vertex is at 2 comma negative 2. See all that work that you had to do in standard form? Don't you like vertex form better now? Because vertex form is literally, hey, does it go right or left? And is it up or down? So it's so much easier in vertex form. So you plot your vertex on that 2 comma negative 2. One other point that you should do is the y-intercept. So the y-intercept is the c value in standard form, because when you plug in 0 for all these x's, this goes away and gives you 0, and you just have 6 left over. So the c value in standard form is your y-intercept, and that'll help you plot your parabola correctly. 1, 2, 3, 4, 5, 6, because you know there's this axis of symmetry. So now you know your parabola, okay, it looks concave up, it looks steeper, right? That's over 2 and up 8, so that's that double the steepness. Usually it's over 2 and up 4, it's over 2 and up 8. So the only other point I have to graph is, where do I go next? So usually I go over 1 and up 1, but it's twice as steep. So I'm going to go over 1 and up 2. I happen to hit the x-axis on the way up, and then there's my parabola. I like the y-intercept because it'll see if you made a mistake with your vertex. So standard form, I think, is going to take a little bit of practice because you haven't done it in 2 years, some of you. You need to have that formula, negative b over 2a, memorized to get the vertex. And it's kind of a long process. All right, so standard form, I think, is going to be the hardest to review. Can I turn the page? Vertex form is going to be the easiest for you because we just spent a whole week on vertex form. So these should be like, oh, that's so much easier to graph. I can already read where the vertex is. You don't have to memorize this, but this is called vertex form written out. So it's A for the steepness, x minus h. H represents if it's going to go right or left, and then plus k represents if it's going to go up or down. A, you saw in standard form, same job. But h and k are different variables instead of like b and c, or different constants, I guess. They have a different job. So k is not c, so it's not the y-intercept anymore. A is still your concavity and your steepness, just like in standard form. H goes right or left, and k this time goes up or down. You're going to see h and k a lot when we get to conics, for an ellipse, for a circle. You do not have to be able to write out this formula up here. I'm not going to ask you to regurgitate that, but when it's written like it is in the examples down below, just knowing, hey, that's called vertex form. So these two you should have been able to graph on your quiz. So let's do them together, but these you should already know how to graph. So this just says to go right 1 and up 3, and it has an a value of 1, so it's just the parent function that's been shifted right 1 and up 3. So right 1 and up 3, there's your vertex, and then over 1, up 1, and over 2, up 1, 2, 3, 4 from that vertex. And it was concave up, parent function up. Does that one feel a little bit easier because we just spent a week on that? So that shouldn't be really any new learning this week. Just practice of those transformation rules again. All right, and then in the second example, you've got -2, so it's going to be concave down, steeper. And then you just have x plus 1 in here with nothing outside, so it's just going left 1. It's not going up or down at all. So left 1 is my vertex, and then it's going concave down with a steepness of 2. So the first set of points is over 1 and down 2 because it's twice as steep. And then it's usually over 2 comma up 4, so we're going to go to 8 this time. So over 2 and down 8. so it's twice as steep as it normally is. All right, and then I think probably in Algebra 2 you skipped intercept form, but I'm not sure. Do you remember seeing intercept form at all with Algebra 2 graphing? I did not do it in CP. I'm not sure if they did it in advanced a year or two ago or not, but this is intercept form, and it is written A x minus P x minus Q. So P and Q have different jobs, but A has the same job that it always has, the steepness and the concavity. This is also called factored form. See the two parentheses? We're going to practice that either tomorrow or Wednesday. So factored form, the reason it's called intercept form is because the factors give you the x-intercepts. So the x-intercepts are at P comma 0 and Q comma 0. The vertex, the x value is halfway between the x-intercepts. So the x value of the vertex is halfway in between the x-intercepts because, again, it's symmetrical. So there's two parentheses. That's what tips you off. Vertex form just has that one parenthesis being squared. And then see how you have the a value in front? So this is a half as steep, concave up. This one is the parent function, just concave down. And if I want to plug in an x value that's going to make this 0, one of the x-intercepts is at -2, because -2 plus 2 gives you 0. And then the zero product property makes this whole thing 0. So one of your x-intercepts is at that opposite. It's at -2, and the other x-intercept is at +4, right? And it says x minus q. Q is the x-intercept when it's that minus sign. So 4 is the x-intercept. 1, 2, 3, 4. So what's halfway in between those two values? I know it's going to go concave up, but what's halfway between -2 and +4? Yep, so the vertex is at 1 comma something. So if I know an x value, how do I find the y value of the vertex? If I know x, what do I do with the x value? Just like in standard form. Plug it in. So once you know x, you can plug x into the original function just like in standard form and find y. So 1/2. I'm plugging in 1. 1 plus 2 gives me 3. And then I'm plugging in 1. 1 minus 4 gives me -3. So 1/2 times -9, right, is what? -4.5. So it's not a perfect nice value here. 1 and then 1, 2, 3, 4.5. So my vertex is at 1 comma -4.5. And it's stretched by a half. So it should make sense that from the vertex, if I go over 1, I'm only going up a half. So it actually hits the y-intercept on an integer. And then see how when we go over 3, we go up 4.5 and we hit that point right there? Right, it's half as steep. Over 3 is usually up 9. Over 3 this time is up 4.5. Let's see, over 2, 2 comma 4, so it's going to be over 2 and up 2. So just do your best to estimate over 2, up 2. You're going to be halfway in between, right? So I'm at what? -1, 2.5. If you can read that, I'm at 1, 2, 3, and then -2.5. So there's my quadratic. I think a stretch of a half is kind of mean. I don't really like the halves, but finding the x-intercept should be okay. This one should be a little bit easier because it's all integers here. So if I'm at an x-intercept of -1 and an x-intercept of +3, I can plot my two x-intercepts and I have to find the halfway point. So what's the halfway point? What's halfway between -1 and 3? 1. So my vertex that's just kind of a coincidence, but my vertex is at 1 again. I have to plug 1 in up here to calculate the y value. So -1 times, so I'm plugging in 1. 1 plus 1 would give me 2. And then 1 minus 3 would give me -2. And it looks like I'll have +4 then, right? Because -2 times -2 is +4 for my vertex. 1, 2, 3, 4. Does it make sense that my vertex is here? Well, remember, I'm concave down, so this is going to look like a concave down parabola, so that checks out. So over 1 down 1, over 2 down 4 I've already got, over 3 and down 9, so I'd be at -5, right? 1, 2, 3, 4, 5. I did not mention the word axis of symmetry or line of symmetry, but your book does. And so line of symmetry just cuts through the vertex vertically. So they call this the axis of symmetry. And in this case, it would be at x equals 1, because that's where that vertical line is. I use it when I graph. I just don't usually draw it on the picture. But I always think about, okay, that's a reflection over the axis of symmetry, so I don't count where this point is. I just use the axis of symmetry. So your book does talk about axis of symmetry, just a vertical line through your vertex. So you've got the introduction to the 3 types of graphing. So I think we should do one more maybe of graphing in standard form together. And then there's a few graphing in standard form, graphing in vertex form, and graphing in intercept form. So I think we should start with maybe doing like 2 of each, and then seeing if we have time, or we could do the rest for a warm up tomorrow. So let's do number 1 together, or maybe I'll do, let's see, I'm going to do 1 and 4 with you, because I don't like the 1/2 as the a value. And then you can try 2 and 3 for standard form. I think the rest will go quicker. Standard form is just the hardest. So it's A, B, and C. So A is 1 in this case, B is -6, and C is +4. It just helps me if I have those written out. Maybe you don't need to write those out. And then you're doing -b divided by 2a. So -b would become +6 because it's already -6. And then 2 times a is just 1. So 2 times 1 is just 2. So my vertex is at 3 comma something. So once I have the x value, I'm going to plug it into my original equation to produce the y value. So I'm going to do 3 squared minus 6 times 3, and then I'm going to add 4. So why don't you do some mental math and think about what that y value would be. It should be -5, right? 9 minus 18 is -9, and then plus 4 would be -5. So my vertex is at 3, -5, 1, 2, 3, 4, 5. And then this is just a parent function from there. So over 1 up 1, over 2 up 4 from the vertex, over 3 up 9. Over 2 up 1, 2, 3, 4. Over 3 up 1. Oh, I forgot that we could find the y-intercept. But when you graph it, I guess you're going to confirm where that y-intercept is. The y-intercept, if you notice, is at 4, and the c value was also 4. So it's just confirming that, yep, we got it right because we got the correct y-intercept from the equation. So let's do one more of those together, and then hopefully you can get through maybe number 10, because 5 through 8 should be pretty quick. All right, so let's do 4. Those darn fractions. So a is -1/2, B is -2, and C is 4. Are you guys factor phobic or fraction phobic? I wonder if there's a word for that. I feel like math students are like, oh, fractions, but they're not that much different or scarier than integers. So start growing your confidence on fractions this year. So I'm going to do -b, which is +2 this time. And then what is 2 times a? So 2 times -1/2 is really just the number -1. 2 times -1/2 is -1. So what is 2 divided by -1? That's just an x value of -2. You're going to plug -2 in to find your y value. So why don't you try to find your y value by plugging it in and using order of operations? When you square -2, you get +4 first. So x squared is going to become +4. So here is example 4 that is finished. And here's my calculation for the vertex. So now we are doing 2, 3, 5, 6, 9, and 10. So this is number 2. The vertex was at -1, -6. This was number 3. The vertex was at 1, 3, and then twice as steep concave down. We looked at 5 and 6, and we kept 7 and 8 as a warm-up for next class. And then we completed 9 and 10, and we saved 11 and 12 as a warm-up for next class.